Okay, we're good. We're good.
All right, let's begin homework. 2.7 questions. Number 20. Okay, what says number 20? What?
I have the information, but I don't know what
The actual problem?
Yeah.
Give me a second. It might be easier.
Yeah, I have.
20 and 2.7?
Yeah, we're doing 2.7 first. Number 20, a boat is pulled on a dock by a rope. Oh, they didn't give you like a picture.
Yeah, but it's a little complicated. You know, I feel like giving us some videos on the why that.
Here's where the boat is. It's attached to a rope to a dock. Here's where the dock is. We know it's actually 1 meter in height. This is the water. Okay, so the things that are changing are the distance from the dock, so that's x, and also the rope, the amount of rope as well, that's y. The height of the dock isn't changing, so that's 1 constant.
How do you understand it though? The problem. Because like if I read it with someone, then I'll understand it, but then it's like the next one I don't know. You know what I mean? Like how, is there an easy way to figure it out? Like what problem it is?
Well, this one, they sort of gave me the picture. I just sort of wanted to get a geometrical shape to it.
You know what I mean though?
Yeah, that's.
Like if I read it, I have to be like, okay, it's a right triangle, and then another one, you're like, oh, it's this, but you have to read it with someone. It's not with their
So why you can't read it by yourself?
No, like the web sign, the snowball one. How are you supposed to draw a snowball, and then how are you supposed to draw the stuff with the right side?
Just in a spherical. Just draw a sphere.
But then you need to know, wait, that was circle area, right? The surface area is easy, because you only have to find the surface area. But like for me,
Alright, well, you tell, when we get to one that you found confusing to set up, you can ask the question. For now, let's do this. So this is step 1. We drew the diagram, we labeled it. What do we know? What do we want? The rope is being pulled in at a rate of 1 meter per second. Where's the rope? It's y. So dy dt equals minus 1. Why is it minus 1? It's decreasing. It's getting shorter as it goes to the dock. And what do we want? We want dt over dt. D what?
Oh, I wrote dy over dt.
You're on y here. You want dx dt when it is 8 meters from the dock, so x equals 8. Okay, so what's the equation?
Yeah, this x squared.
So I think this was step 2. The equation was step 3. Pythagoras' theorem. So we know that 1 plus x squared is equal to y squared. And so step 4, implicitly differentiate with respect to t. These can cancel. I'm looking for dx dt. Now I'd like to plug in. I know the x, but I don't know the y. So how do I find the y?
Go back to the 7.
Right, so when x equals 8, we have 1 plus 8 squared equals y squared. So y equals radical 65. This means the x dt is equal to radical 65 times dy dt, which is minus 1, over x, which is 8. Does it make sense for this to be negative?
Yes.
Yes, because as you're getting closer to the dot, x is getting smaller, it's decreasing. So that was the answer. Water is leaking out of inverted conical tank. So the water is leaking out. It's also being pumped into the tank. Okay, so that's our diagram basically. Right, so now what? What do we know?
Total height 6 meters.
The tank has a height 6, so this is 6. Diameter is 4. What do we want to call the height of the water? H. You call it H.
And we also need the small r.
All right, we can talk about here. The radius of this we can call r, and here the big R is 2. Okay, so that seems fine. So what do we know?
We know how much rate it's decreasing per volume. It's minus.
The water level is rising at a rate of 20. So dH dt is positive 20. What else do we know?
We know radius.
What else do we know? So we know this is leaking out. So this gives at what? 10,000. So there's the rate here is minus 10,000. What's the rate coming in? So this is rate out.
Constant.
Rate in is what?
You just
We don't know. So it's a constant. So C is just a constant. We don't know that yet. We're going to want to determine that.
There's the 10,000 centimeters.
Yeah, centimeter cubed.
Isn't it better to like put everything into 1 unit?
Come again?
It's like PHCP is also 20 centimeters. It's not really.
Yes, H is a height. This one is a volume.
Right, but everything else is in meters. So you gotta cover everything. Yeah.
Everything here looks like centimeters.
Centimeters. Yeah.
Oh, you mean the heights of the actual tank?
Right. So isn't it better to just put them in terms of 1 unit?
Sure, yeah. So this would be how many centimeters? 600? This would be 200. This would be 400. Okay. What else do we know? Do we actually know dV dt?
Minus or constant.
It's going to be constant minus what's coming out. Right? Does everyone see why? Right, the thing that's coming in is just going to be added to the rate. What's going on is going to be subtracted. So you can sort of figure this out by coming up with an example. You know, what if, you know, after every minute, 3 gallons are coming in and 2 is coming out? How is it changing? By 1, right? How do you get that? 3 minus the 2. You get 1, a net change of 1. So it's always going to be rate in minus rate out. So that's good enough. What do we really want? C. Well, we want C. So in order to find C, we need to really, at the end of the day, find dV dt. Right? If we find dV dt, we can just solve for C by subtracting 10,000. When do we want it?
Minus 200 centimeters.
When H is
200 centimeters.
200 centimeters. Okay. All right. So that's setting up the problem. Now, what's our equation going to look like?
V equals 1 over 3 pi r squared.
Okay, what's the problem here? Huh? The R is a problem. We don't know anything about the R. We're going to want to turn the R to H. How are we going to do that? Similar triangles, right? So basically, you kind of slice this here into a triangle. And it's going to look like here, that's R. This is going to be H. The whole thing is going to be 600. The whole thing here is going to be 200. So we're going to want to rewrite R. So this means that R over H is equal to 200 over 600. So that's just 1/3. This means that R is equal to H over 3. And we just plug that in.
It's supposed to be R over 100.
Well, if you put R over 200 equals H over 600, it's the same thing as well. It's not going to make a difference. R is going to be 1/3. So this would be 1/3 pi times H over 3 squared times H. That's going to be 1 over 27 pi H cubed. All right, now we can differentiate. What's that going to be?
1 over 1.
Now we plug in. This guy is C minus 10,000 equals 1 over 9 pi times H. 200 squared times DH. 20. So this would mean that your C is actually just 10,000 plus pi over 9 times 20 times 200 squared. And what was that? What? 2.9 times 10 to the 5? And that's in centimeters cubed per minute.
Professor, whenever I'm being converted, you still get prosperity. Because I think on what the side they need the same question, but you have to.
No, you can't. No,
Oh, yeah,
you have to.
yeah.
That 200 has to be in centimeters because this is in centimeters.
All right.
So this was kind of tricky. The only part that made this tricky really is figuring out that dV dt was this. But then usually with these inverted conical things, it's similar triangles going to be the trick to eliminate one of the variables. It's a very typical kind of problem. Other questions? 39? 20. Come on, Rashad, come on. Fair. Two sides of a triangle are 4 and 5 in length, and the angle between them is increasing at a rate of plot. Okay, so it's my triangle. Let me say this side is 4, that side is 5. It's constant, right? They just say they're 4 or 5, they're not changing length. The angle between them is increasing though. So I'll put a variable here. So that's our triangle. That's step 1. Step 2 is what do we know, what do we want? What do we know? d theta dt is equal to 0.06 radians per second. Okay. What do we want? Find the rate at which the area, right? So we want dA dt when theta is pi over 3. Okay. What's the relationship? Huh?
A equal to 4 times 5 times 19.
No.
Oh,
1/2. 4 times 5 times 9 theta. Right, this is from geometry class where we know if we have a triangle ABC, this is theta, and the area is 1/2 AB sine. Okay. So that's our relationship. So it's just 10 sine theta. So now you find the derivative with respect to t. It's going to be step 4. Derivative this. Pi dt equals, so when theta equals pi over 3, dAdt equals 10 cosine pi over 3 times 0.06. Cosine pi over 3 is? Right, that's a half. So that's what, 0.3? And I don't particularly care about the units, but you can write the units if you want, which here would be meters. Other questions?
Professor, you said you will not care about units, right?
No, I wouldn't.
And let's say we wrote the units and it's wrong.
So in this question, right, you had to change the units because the actual numbers would be off, right? But as far as you writing CMQ here, I don't really care.
You don't care if it's a mistake, right? The unit.
No, if you write it wrong thing, I will take all points. Just, if you're not sure, just don't write anything. You're fine. I can't see the wrong thing and not punish it. And what? The ones I'm collecting today?
Yeah.
Okay.
Where do you put the answers for like NYU worksheet?
I didn't do the answers.
Oh, you didn't put the answers down? Oh, so now how are we supposed to study that?
Listen, no. Study in a group.
Okay.
Someone stole the question. You want me to like? I'm gonna get caught. I can't spend all that time.
And your video.
impersonating my professor. So, you know, this is really Are you a professor here? Of course. Any other questions on 2.7?
No. Just on linear approximation.
Questions on 2.8? And Richard is ready.
People see that on YouTube, that's why you just hold up.
I don't know, I'll censor that part out. I need a video editor. Yes.
Can you do the linear approximation without a calculator?
Yeah, like you do it without a calculator. Like calculators aren't allowed.
Because like you know, when they say find the linear approximation to a certain number, like
You might have to use a calculator here, but I'll give you nice enough numbers on a test to do it by hand.
yeah, that's what I was wondering because a lot of us we have to use calculators.
Yeah.
We're not
Yeah,
supposed
that's
to
normal. Just know that if it were easy numbers that you could do by hand, you should know how to do it.
Yeah, and I tried to do it with that.
So, questions on 2.8? Huh? Alright, calm down, I can't hear it. Use differentials to estimate the amount of heat needed to apply a code of clean. 0.05. Alright, so what's the picture here? You guys realize what's going on?
Sorry?
What does a hemisphere look like? Half the sphere. So we have this hemispherical dome, right? And we're actually going to paint it such that, so the paint is on top of it. I'm drawing an extra thick. Right? This is like the paint. Right? Now this distance here is 0.05 centimeters. Right? So they talk about diameter, right? So the diameter would be this guy, d equals 50. This extra bit here, I can think of as the change in the diameter, right? The differential. Right? Is there anything other thickness that I need to care about in this case? That's it. I don't care about thickness here. Should you care? Should be the question. Okay, let's move on. Let's see what we got. So what would be the volume of this?
Half of the street volume.
So here, how do you want to do it? So you want to call it something else? Let's start with the volume. So the volume is what? Huh? What's the volume of a whole sphere? And we want half of it, right? And so now, actually, what's going to happen, dV is going to be the amount of heat. So now what? What is dV? Oh, by the way, don't we need to change this thing? Because we know about diameter. And we have V equals 2/3 pi. R is half the diameter. So So this is d cubed over 8. This goes that 4 times, so it's d cubed over 12. This means that the differential is power of 4 squared d. So this means when d equals 50 and dp equals 0.05, then and that's going to be what? This is what? 25 This is 5 over 100 over 4. 525 is 125 over 4. They told us the diameter changed by 0.05. I thought they said that.
I mean, if you're adding 0.05.
It should be 0.1.
Right.
Right, because it's the diameter extends in 2 directions. This is actually 0.1. Which is just 1 over 10. So I would add a 0 here. This would actually be 10. So this is can I take 4 into 250? Okay, that's it. Other questions?
How late can we go?
I don't know that funny.
That
Which is from Wicked or something.
well, they're on
Okay,
the
what are
videos.
we, any other questions? 19. You know that y is equal to tangent x. A, find the differential dy. Your tangent is? That's part A. Part B. Evaluate dy, change of y is x equals power of 4 and dx is that. What do we do?
Evaluate. So secant pi over 4, secant.
So dy would actually be, you plug that in. This is pi over 4 equals times dx minus 0.1. What's secant of pi over 4? Huh? The squared is 2. Yes. So that's just 2 times minus 0.1. This is minus 0.2. What is delta y? It's the actual difference in the y value, right?
Yeah.
So delta y equals tangent of. Remember, delta y is the actual change in the y values, right? So you're looking at the graph tangent, and you're looking if x value changes by minus 0.1, what would the y value change by? tangent is increasing at that point. So this would be pi over 4 over 2. Pi over 4 plus remember, the idea is tangent between 0 and pi over 2 looks like this. We are at pi over 4, which is here. Now if your x value moves in this direction, this would be pi over 4 minus 0.1. You want to know what is the actual change in the y values. Well, it's going to be tangent of pi over 4. And this is going to be tangent of pi over 4 minus 0.1. And this is a minus.
But you can be a little more clear on the how you got the values for changing y.
Come again?
Can you like repeat again like how you got the values for changing y?
It's the actual change in the function. Right, remember dy is the approximated change using the tangent line.
Yeah.
Right? So to actually draw this on the picture. Let's say here's where you have that pi over 4. Right? You would draw a tangent line at pi over 4. And the distance between the function and the tangent line at pi over 4 minus 0.1, that distance here is dy. The actual distance between the y value, that is delta y. Right? So delta y uses the actual formula for the function. Dy is using the tangent line as an approximation. So we're measuring the distance between the function and the tangent line as opposed to the function and another point of the function. That's the difference. Well, yeah, I mean, you would put this in a calculator, but on a test, you wouldn't have a calculator, so you can read it. Well, tangent of pi over 4 is you could simplify that more, but no one remembers the addition of 4 by tangents. Other questions?
What values you just use f of the
Yeah, f of the higher y value minus f of the smaller one.
and over this I was confused on how which one is a and which one is
It's the right one is the b. It's ab. Right? Do f of b minus f of a.
f of a minus f of b.
F of b minus f of a. Always right minus left.
F of b minus f of a.
Other questions on the homework? 21.
Wow. Really?
So we have a cube. And there is some error around this cube. So sorry, send me with a positive error. So this distance here is 0.1. So if I want to call this distance here x, and I know that x is really 30 and dx is dx would be what in this case? Point 2, because it comes over on the other side, right? There's a gap over here as well.
Oh.
now we want to the positive error in computing the volume. So let's look at part A, volume. So we know that volume is just x cubed. This means that dV is equal to 3x squared x. This means that change in volume is equal to 3 times 30 squared times 1, 2. And what's that? Mm-hmm. 900 times 3 is
1,800.
2,700.
Sorry, I said something unlike other people.
So this is 2,700 times 2 over 10, right? Because that's 0.2.
Yeah.
So then,
0, 0 cross out. 2, 0, 0, 2, 7.
huh?
I was doing backwards.
540. Yeah,
I just saw
So it says, so max possible error equals 540 centimeters cubed. It also asks for the relative error. This is just 540 cm cubed divided by the actual volume, which is what? 30 cubed. Right? So that would be, I don't know, whatever. And then percentage error. Would be blah times 100%.
Isn't it like actual for
Yes, this was the error over the actual volume. Yeah, and part B is the same thing except use the surface area equation, which would just be 6x squared. Right, and we do the same thing with 6x squared. Let's stop there. What time is it? Okay, so you guys want to move on to chapter 3 or do you want to
We
review?
just want to review.
Review. Okay, what do you want to review?
Oh, I have a question. Can we put up some problems and then we can try them and like our mistakes like together or something?
Yeah.
Like, you know what I mean?
Okay.
Okay?
You mean like what he normally does?
Okay, let's look at, I don't know, fall. Let's look at fall 2011.
It was hard problem. I'm tired of eating problems.
I have no idea what you're talking about.
Calculate the rate of change of the planet. D airplane. D airplane.
Do I have to write this out? You guys have to.
Don't write it down.
Well, 5 is a word problem. Finish that. 7, 8.
Is this all chapters? Presentation?
Professor, do it or you want to do it? I can
We're going to do it together. All right, we're going to do problem 1 right now. Maudi, what's it? What is it?
3 over 2 x and this 1 over 2 minus, so 9
9 x minus 3 by 2.
Maudi's
It's
doing
not
it.
just a negative.
Last 9
minus 9
last 9 count. Next one is on
Negative 5 over 2.
Maudi's doing it.
is minus 9x and minus 2 to the power.
To the power minus 2.
No, you guys think why it's this
Let me do it now.
Maudi's doing it. Is that right?
Do it in second.
Is it plus 5 over 2x instead of negative something?
No.
Okay.
Wait. 5 over 2x? No.
No.
Why is 5?
Isn't it the negative?
No, minus
Minus 3 by 2.
Negative versus 9x to the negative half.
Sure, you can write it like, rewrite it first, so you don't confuse yourself. This is x to the 3 over 2 minus 9x to the minus 1 over 2. So y prime would be?
So
3 over 2x.
3 over 2x minus 1 over 2.
No,
Positive 1 over 2.
Okay, so it's going to be plus 9 over 2 x minus 3.
Oh.
But how do you simplify that to a single fraction?
Why would you want
Because
it?
I was gonna find it said right at a simplified fraction.
Factor that.
Nah, leave that.
I think that's I didn't do that. That's not.
I can do it.
Okay, who can do this one right now? Yeah?
2x squared.
I mean, I thought.
3x squared.
Cos square 4x plus 2 cos 4x minus sin x plus sin 4x
2 cos 4x
and then back parenthesis minus sin 4x.
minus sin 4x.
Yes.
Like that?
I mean multiply by minus. Then there's yes. Then 4 multiply by 4 and then x cubed.
And then the x
Multiply
cubed.
by x cubed. Yeah. Yes.
So, can you simplify that?
Minus 8.
Oh, you're doing here?
Yes. So that's minus 8 cos 4x sin 4x x cubed.
Let's throw words out there.
Yeah.
It's
For what part? For the original, what did you do? Product rule. You differentiate this, leave that alone, then you differentiate this, leave the first one alone. That's what he did here. And you use the chain rule to differentiate cosine squared for x. So you differentiate the outside function, which is the square, bring that 2 down, subtract 1 to the power, multiply by derivative inside, which is minus sine for x times 4. And then you left the x cubed alone. Can you simplify this more?
Yeah. Sure. X squared plus
Yes.
You can take x squared
X squared plus
square, so cos for x, yeah, cos for x. So that leaves you with 3 cos for x minus 8 sin for x.
8 sine for x. Are you sure? He's doing it, he's doing it.
Oh yeah, 8x sin for x. You have x squared, it's true.
Wait, you needed the product rule and the chain rule within the product rule?
Yes. To differentiate the cosine squared, you have to do.
And then you have to simplify that.
Yep. They expect you to simplify something like that. Not like this, but like that. Sure. Okay, so I gave Iftikhar 1 bonus quiz point. Who can do this one right away?
Which one?
This one.
Oh, 5? Oh, this one.
Like right now.
Yeah.
That's
5. 5.
This would give you one.
5y to the 4.
I pointed at him. At the back. Please put his hand up first.
Use the chain for 5 lines.
Yeah, so this gives you one.
5 lines to the 4. 1 prime or plus use 5 rule, so I did x times 5 prime plus 1 times y equals 0. And then you want to just move the y over to the right side. You do 5 y equals 4 prime plus x y prime to the negative 1. And then y prime in the end is just going to be equal to negative y over 5y to the 4 plus x. And then you plug in the limits to column 1. You're going to get y prime equal to negative 1 over 5 times 1 to the 4th.
5 times 1 to the 4th.
Yeah, whatever. Yeah, and then plus 2. So you get negative 1.
Okay, and that's Lewis. Yes. Okay, it's a tough one. You're going to have to do a tough one. Huh? Alright? So I'll make that one worth 2 points. Andy.
Yeah. Take that so we know the points like last time. Shadow?
What is it?
Jeez. Talk about confidence. He's like, whatever it is, it doesn't matter. I'll solve it. That's the question.
He's like,
I'll do it. Doesn't even know what it is. Challenge accepted.
Count 3 on your phone. You should have doubled up though. If you got it wrong, then it gets -2. On the board. Risk. It should, right? Am I saying this? Okay. So for the first, the question is, a person 6 feet tall walks away from a street light which is 24 feet above the ground.
Okay.
So there's 2 lines, like 6 and.
Draw the picture on the thing. Draw the picture on
How
the
about you not write it on the board?
You can come right.
Yeah.
That's the actual board.
Show us the problem.
You didn't know what he was getting into.
Okay, is that down?
So there's a person, he's 6 feet tall. There's also there's a light, there's a street light This is 24 feet. They're on the same level.
Okay.
So the question is asking how long is the person's shadow when the person is standing 9 feet? This is 9 feet. From the street light. Justify your answer. Okay.
Justify your answer.
The shadow is coming from this. So I guess if you create a square triangle like this is some x. We say x over 6 equals 9 plus x over 24. So the algebra. Plus 6x. The guy's shadow is 3 feet. And B is asking for the shadow is lengthening at the rate of 50 per second.
It says, how long is the person shadow when the person is standing 9 feet?
If the shadow is lengthening at the rate of 3 feet per second. What rate of progress?
All right, calm down. You need to think. Shh. What's your y?
I'm saying y is 9 plus like 7x.
Sure, I'm gonna ask someone to. Well, partly or both. What about B? Anyone think they know how to approach B? There's a 24-foot light pole. There's a guy who's 6 feet tall walking away from the light pole. And we want to figure out what, if we know how his length, the length of his shadow is increasing, at what rate is the person walking?
So he's walking that way?
Walking away from it. Wait, walks away from the street light. Right, he's walking that way.
So then his shadow
shadows increase?
No, it's positive.
The
Increase.
shadow would be increasing, yes. Is this diagram good enough to encapsulate the problem?
No.
What's wrong with it?
Nah, I think I'm not.
Is this always 9 feet? It's increasing.
Oh, yeah. It's changing.
This is changing.
Yeah.
What do we do with things that are changing? Label them with variables. So you can call this y if you like, call this x. This is 6, this is 24, right? That's the correct diagram setup.
Alright.
And of course we can use similar triangles, right? So we say base over height for the small one is equal to base over height for the big one, right? So that's our equation, that's our relationship. Now they told us, what do we know?
You know the rate which is shadows.
We know the rate of the shadow is lengthening, which is dx dt, right? Which is what? Huh? That's just 3. And we're assuming this is where you want dy dt is what we want, exactly. When it's the same situation for part A, x equals 9. Right? So when x equals 9, when the person is standing 9 feet from the street light, when y equals 9. Okay, so now how do we solve the problem? Huh?
You find the derivative of that, x over 6.
Okay, which is going to be?
No, dx
dx dt equals?
Because all this intervals was
1 over 24 dx equals dy dt.
Yeah.
Right, dx dt plus dy dt
Yeah.
all over 24. And we know dx dt. X and y don't even come into play here. Right, so we know dx dt is 3. And we know, so that's 3 plus dy dt over 24. So this is a half times 24, that's 12 minus 3 equals dy dt. It's walking at 9 feet per second, that's part B. Part A was fine, but even if you did this general setup, what you do is you plug in 9 for the y, and then you solve for the x. Huh?
No.
Yeah, so if you had done this general setup for part A, all you do is you plug in 9 here, and then solve for the x, the length of the shadow, and if you do that, right, so this was correct, because he did it as an intent, so I guess only 1 point.
Professor, I was going to do the next problem using these.
Okay, what's the next problem? State the definition of a derivative. Alright, Gil's in, we'll just do this one.
Just a definition.
Yes, that's part A. Definition of derivatives for a function f of x.
So it's f of x plus h minus f of x over h. Yeah. H, and on the left side you have to write limit as h approaches.
I don't know what it is, I know what's important.
That's it.
Is that your final answer? Define the derivative?
You forgot the equals.
Equals.
No? Why? Equals what?
So that,
Equals what?
You forgot the equals.
I forgot it. I wrote down what you told me to write down.
You guys supposed to write that from X.
Yes. If you didn't, I would have taken off a point. That's correct. B. It says use the definition to find f of x equals 1 minus 3 over x. Find the derivative using the definition. How do you do it? That's the function. What is it?
I have to get that for what you
Okay, let's see where it goes. So he put, well, you didn't write the limit the whole way down. On the test, you lose points for that.
Yeah.
I think you're just doing it. Okay, so we have 1 minus 3 over x plus h minus 1 minus 3 over x all over h. Then you actually combine the fractions here. That's working harder than you have to. The 1 would just kill this one. You just have minus 3 over x plus h plus 3 over x all over h. Just kill the 1. Don't waste time combining them. And then we would have LCD here is x times x plus h. You do that at some point. Okay, so then this would be times this, the x plus h goes away, you just have minus 3x plus. Here, the x cancel, you have plus 3x plus 3h all over h x plus h. These two die, the h would cancel that h, and you just have the limit as h approaches 0 of 3 over x times x plus h. So x squared. Okay, you have that correct. And so now we want the tangent line at the point minus 1 comma 4.
Is that a problem, like something like that on the test, or like more complicated?
I probably wouldn't give you a 1 here. Maybe like an x. Okay, so it's y minus the y value equals n, which you took to be, right, you plug in minus 1 for the x, so the slope here is 3.
Yeah.
3x minus the x value, which is 3 plus 1. Okay, you got it. Yes. What? No, you can't get bonus on the final. Yes. You want the next one? 11?
What's the next one?
The next one's really good.
Really?
It has 3 parts. You can get 3 points.
Really?
Did I got 3 points for that?
Yo, we got 3 points.
The whole velocity, right?
Yeah, really.
Yeah.
You do it?
Yeah. Thank you.
Like quickly?
Yeah.
Here's chalk. Come over here. Okay, she's going to attempt number 11. It's a 3-point question with velocity, position, velocity.
The only time I've ever seen physics.
So A actually find the position, the velocity, and acceleration after t seconds. So label them. Which one? Who's called position?
This is the velocity. This is the acceleration. I don't know how to find position, so if you give me like 2 minutes.
What?
Oh, okay. How does the next flow
So far,
yeah. Oh, yeah.
I think you can do 12A. All right, go do it.
It feels like we are going back to the high school.
Look at like the paper. I don't want to shit.
I can't film both at the same time. I like editing the video. Doing fun. I'm gonna go back to her. Hold on.
Just focus on her until you We have like 3 minutes. You guys better hurry up.
Are you collecting?
Of course, we're collecting.
It's 120.
Yes, it's on. Yep, go into the class.
It should be negative 1.
This is where it's at.
What is 12? Linear, oh, yeah, approximations. Oh, approximation.
What does that mean? What do I use for that? Come on. I'll give you the full record. Can I get help? Really? Okay, so I'm done. I don't know what that is.
What is what?
The total distance the particle travels from 0 to pi over 3.
Total distance.
Yeah, what's the change in position?
Cancel that. There's 2 points. The x and y. 0, comma, 2. What is this?
2 pi over 3. Distance traveled.
I remember what this was.
They can't get it to I get it.
Oh, chaos.
Who understands it?
Javon, I know the answer.
You can turn it off.